The outermost part of the human brain is called the cerebral cortex, and it's kind of like a computer. It takes input from the world around you, processes that information, and outputs a response. For example, imagine picking up a pencil. First, your cortex takes visual information about where that pencil's located. Then it makes a plan of action and signals the muscles in your arm, hand, and fingers to reach out and grasp that pencil with absolute precision. Now imagine a robot trying to do this same simple task. It's slow and robotic, even though the computer in that robot is 10 million times faster than the human brain. But we understand so little about how the cortex is wired that we simply can't apply the same principles to modern technology. And so I want to understand exactly how the cortex computes. And in doing this, I expect to prove a Nobel Prize-winning theory wrong. For over a century, it's been widely accepted that the neuron, the main type of brain cell, is the basic unit of structure and function in the brain. However, unlike anywhere else in the brain, neurons in the cortex are curiously wired into tiny, compact vertical circuits called mini-columns. And there's substantial evidence to suggest that these mini-column circuits might act kind of like parallel processors to speed up data transmission over what would be possible with single neurons alone. And so it just might be that the mini-column, rather than the individual neuron, is actually the basic unit of function, at least in the cortex. Unfortunately, this is a challenging theory to address, simply because we can't distinguish one mini-column from another in the brains of animals. And so I've come up with a way to make a mouse in which we can see mini-columns very clearly. And to do this, I've added genes to the brain cells of mice that, when turned on, produce a rainbow, where all of the brain cells become different colors. And I can take advantage of the fact that one whole mini-column circuit arises from the identical copies of one parent cell. And so if I turn on these color genes just before the cortex begins forming in the womb, then each new resulting mini-column will be exactly the same color as its parent cell, and yet easily distinguishable from neighboring mini-columns as different colors. And ultimately, I can use this mini-column brainbow in combination with existing technologies that allow me to watch individual neurons and now whole mini-columns engage in data transmission with one another. And this will not only help me better understand exactly how the mini-column is enhancing cortical computation and thus interacting better in the brain, but it will also eventually help to improve robotics and artificial intelligence by applying what we learn about one computer to another. Thank you.